Hi, this is Rajav here, and today we're going to take a look at dynamic testing techniques. Black box testing techniques are actually dynamic testing techniques, that is, a code or executed to identify errors. To start with, black box testing is a very important strategy whereby input are driven to the system and then the outputs are observed. So what we do is we view the program as a black box. That is, we don't take a look to the internal structure or program logic of the program, and at the same time we try to feed in a large number of inputs to identify whether the correct outputs are given or not. So basically you can easily identify some of the disadvantages of black box testing, such as you don't know whether all the paths are being exercised while executing the test cases, and it is actually a big problem when it comes to design of test cases, right? And most of the advantages that you can have is since code logic are not involved, so actually the testers that are involved during this process will be actually not included in the development team, right? So it is not necessary that the testers to form part of the development team and analyze the code. So our main goal will be to be completely unconcerned about the internal behavior and the structure of the program itself. And let's concentrate on what will be circumstances when inputs are actually driven into the system. So one of the main important topic that I would like to discuss is exhaustive testing. What is exhaustive testing? You keep feeding the program with a large number of inputs, and then based on these inputs you're going to analyze the output, whether it is a correct output expected based on the system specification. So since we don't have the logical view of the program, what we're going to take a look is the specification. For example, if a program is going to do a sum, we're going to analyze whether if I'm passing 3 and 4, it's actually getting me the right value, or if I'm saying that a program will calculate the sum of positive values only, so whether the program will accept negative value can be a test case. Now the main problem that black box testing come across is exhaustive testing. A large number of test cases may be designed to test it because no logical view of the system. So we try to feed in as many inputs as we can to the system and analyze the output. But to overcome this problem of exhaustive testing, different scenarios, different techniques, major techniques have been produced, such as equivalence partitioning and boundary value analysis. This will allow us to come across a set of test cases that are very important. And they are good, right? So when it comes to good test cases, you must take into consideration that a good test cases first allow you to minimize the time cost and at the same time increase the probability of finding a defect in the system. So up to the tester, we try to find good test cases based on equivalence partitioning and boundary value analysis. For this section, we're going to take a look at equivalence partitioning and what are the different stages involved in equivalence partitioning. So when it comes to a good test case, like I've said, is one that has reasonable probability of finding an error. Like I said, exhaustive input testing is completely impossible. There are infinite number of test cases that can be driven into the system, but it becomes a problem to test all of them. Now just imagine that you have a deadline during the SDLC, the software development life cycle, And during this course, what you have is a large number of test cases that may cost you days writing unit test cases for them, right? So exhaustive input test is very difficult. Now let's come to equivalence partitioning. So it involves two steps. First, we identify the equivalence classes, and then we define the test cases. We're going to look at an example. So let's say you have a range of values. For example, an item count can be from 1 to 999. So we identify one equivalence classes that is in between 1 and 999, and then we identify item count less than 1 and item count greater than 999. But basically here that should be less equal because it is between from 1 to 999 inclusive. If an input condition specifies the number of values, for example 1 through 6 owners can be listed for the automobile. So what we do is we define one valid equivalence class and two invalid equivalence classes, no owners and more than 6 owners. Now if you have a set of maybe check field, bus, truck, check boxes, taxi cab, passenger or motorcycle, where you can choose either one of them, so you can identify a valid equivalence class for each. For bus, it may be replaced by trailer, or bus may be replaced by bicycle, obviously, in case if you have another type of vehicle listed, right? So if an input condition specifies a must be situation, therefore it is a letter, it will be not a letter. Now we're going to take a very quick example and try to discuss how the equivalent clauses will apply. Right. Assume that you're a software tester at soft company. You're going to test a module at the client side for the pizza home delivery. The module takes a name, age, and phone number. So as you can see, the name is alphabetic from 3 to 13 length. Age may be a value between 18 to 100, and phone numbers are 7 numeric characters. So your job is first to identify the equivalent clauses and assume inputs that you're going to feed into the system is going to be delimited by a comma. We try to write down 5 test cases for which the expected outcome is false or invalid. So the first scenario is name is alphabetic. Like I said, if it is said that the name is alphabetic, therefore this is a must condition. So you will have two important conditions here. Name is alphabetic. Name is not alphabetic. So this it can be numeric, but not necessarily numeric. So we just write down name is numeric. Now, for this range of values, that is from 3 to 13 length, what we try to do is we try to break this into two. First, this is going to be a valid clause where the name is of length. Name is of length 3 to 30 characters in length. Second, we'll have one that is lesser than this value. Name is less than 3 characters, and the fifth value would be name is greater than 30 characters. Right? Now age may be a value between 18 to 100. So this it can be 18, can be 100 in between, assuming that it's going to be inclusive. So we have one valid condition. Age is between 18 and 100. Second valid condition will be age is less than 18. Age is greater than 100. Okay, so this is a valid condition, I mean valid clause, and these two are the invalid clause. Now 4 numbers or 7 numeric characters. So let's take a look how this can be done. So first, there are two important scenarios here. First, it is 7 numeric characters and it is 7 in length. That is, it is a must that it is 7. So we're going to have two scenarios here. I mean maybe 4. So 4 numbers are 7 in length. Okay, so it's a must, remember. So we need to specify not a range but or not 7 in length. 11, 4 numbers are numeric. 12, 4 numbers are not numeric. Right, so this is a very important test case that we have, I mean equivalence clauses. 12 equivalence clauses. Like I said, beware when you ask between a must condition and a range condition. These are two different scenarios. Right, so now it will become a bit difficult for me to write down the test cases. But since we're going to